area of composite shapes. Composite shape is made up of two or more plane shapes. The area of a composite shape is then calculated by adding and subtracting the areas of each plane shape. And a good example of this is an ice cream cone in the 2D world anyway, where we have a triangle and then part of a circle. So you can calculate that area by calculating this part of the circle and then adding on to the triangle. It's harder than you think, just so you know. Don't try and do that, please. To actually find the area of the composite shapes, there's at least 4 steps that we need to go through. It will feel like more, but we'll just start off with 4. The first is to divide the composite shapes into 2 or more plane shapes. So that's like circles, squares, rectangles, things that you know how to find the area of quite easily with one formula. Then you need to calculate that area. Once you've got all the areas of the shape, you need to add or subtract. Depends on the question whether or not you have to add or subtract. You'll see in a couple of examples. Once you've done that, you need to write the answer with the correct units, checking the number of decimal places from the question. So, for the first example we'll look at today, there's a concrete area in the shopping centre, and it consists of a square and a triangle. The square is a side length of 12 metres, and the triangle is isosceles. So you need to use a bit of your understanding of these words in order to answer this question. So there's 2 parts. The first, use Pythagoras' theorem to find the value of x, and B, calculate the area of the shaded region. So for part A, use Pythagoras' theorem. So first of all, we should just write Pythagoras' theorem and draw a picture, because we didn't actually have a picture. Now here's our square of 12 meters in each length, and the triangle is isosceles. What that tells us is that this leg and this leg will be the same, because that's what isosceles means. It means same legs. So as long as those are the same, we can get this drawing and we can start to work out the actual answer to the question. So using Pythagoras' theorem, we know that this number squared plus this number squared equals this number squared. So let's put it into the formula. We have x squared, and as these are the same length, plus x squared, and that will be equal to 12 squared, because this is the same length as this side here. We'll evaluate those. So x squared plus x squared is, of course, 2x squared, and you type into the calculator, or if you just know, 12 squared is 144. Then we need to divide both sides by 2 in order to get rid of this 2 in front of the 2x squared. And that brings us to x squared is equal to 72. But that's actually not the length. That's the length of x squared, or the size of x squared. So we need to then square root both sides, and we get the square root of 72. We don't have to evaluate it. In fact, if you evaluate it, the rest of your answer will be most likely wrong or off by just a little bit. So leave it in this form. It's called exact form. Okay, just a reminder of the question. And part B, calculate the area of the shaded region. So looking back to our shape, we need to calculate the area of the triangle and the square. We'll do the square first. So the area of the square is, of course, side squared, or you could do base times height, or length times width, whatever you prefer for your square. And so that's going to be 12 squared. So 12 squared is, of course, 144. And as we found out before, and it's meters squared because the distance is in meters. Now to find the size of the triangle, we've got, of course, the formula half equals base times height. And we know the base and the height, because as this is a right angle triangle, that means it's perpendicular. So if you turn it, which I can't do right now, but try and imagine, tilt your head, this will be the base and that will be the height, but they're the same length. So we can type into our calculator a half times 72, or the square root of 72, times the square root of 72, and that will give us 36 meters squared. But unfortunately we're not done, because we need to add them together. So the total is the area of the square plus the area of the triangle, which, as we worked out before, is 144 for the square and 36 for the triangle. And when you add them together, you get 180 meters squared. So that is the area of the shaded region. Next example, we have a square with a side length of 6 centimeters and it's cut from a triangle with a base of 24 centimeters and height of 16 centimeters. What is the shaded area? Just like with the last question, conceptualizing this is part of the difficulty of these questions. So a square with a side length of 6 is cut from a triangle with a base of 24 centimeters and height of 16. Well, after a bit of thinking, we end up getting a picture like this. Oh my goodness. I really hope you were able to find that out, but if not, like, all normal people, hopefully the question will give you a picture, but if not, just try your best, draw a picture, and even if the picture's wrong but your working is correct, you still will just get one less than the full marks, most likely. Depends how easy you make the question for yourself. So, we need to start going through this. It says, what is the area of the shaded area? What is the shaded area? So, we know we've got a triangle here, and it's got a base of 24 and a height of 16. Okay, so our half times base times height, that's going to be a half times 24 times 16. You type that into your calculator and you get 192 centimeters squared. So that's the triangle part done. Now we need to find the area of the square. So we know from the question, a square with a side length of 6 centimeters is cut from a triangle. So there's our square there, and we've cut it out. So it's got a side length of 6. So if we do 6 squared, we end up getting 36 centimeters squared. So now we need to put it together. But this is where we need to subtract because the square was taken away from the triangle instead of being added on. So the area of the total is equal to the area of the triangle, take away the area of the square. These are formulas that we've had to make up because of the question, so they change. It's not like the area of a square, it's always going to be the same. This one you have to think about a bit more and make it yourself. So the area of the triangle is 192 and the area of the square is 36. We subtract 36 from 192 and we get 156 centimeters squared. And that is, of course, the shaded area. Now, the last example, we've got 3 parts to this one. The diagram shows a semicircle cut out of a semicircle. What is the area of the smaller semicircle? A. What is the area of the larger semicircle, which is B? And then C, what is the shaded area, correct to 1 decimal place? Now, we've given you this picture here, as you can tell from the question. So there's our smaller semicircle cut out from our larger semicircle. Now there's a couple of ways to solve this, but I'll just show you the way I solved it. We have our semicircle formula, which is a half pi r squared. We learnt that last lesson. And now we're doing it for the smaller semicircle, and you'll know that because I used all lowercase, of course, for the smaller semicircle, and you'll be blown away by the larger semicircle. So we've got half times pi r squared. Well, pi stays the same, half stays the same, so it's just the radius, which is 4. So that is our area. And now, this time when I type it into the calculator, I'm going to leave pi out. And this is so I can get an exact answer. So that means I'll type in a half times 4 squared, which gives me 8. So my answer is actually 8 pi. Kind of like how you'd write it if it was algebra. Okay. This is just as right as if you type it into the calculator and get a decimal. But we'll need this number later, and we don't want to approximate too early. So we're going to leave it as 8 pi. Next, for part B, what is the area of the largest semicircle? Well, boom, there it is. There's the large semicircle. And now we have to think a little bit because it says 16 here, but that's the diameter. So we need to halve that, so it's going to be 8. And we use the same formula that we used last time. So when we substitute in, the only thing we're adding in now is the 8 squared. So don't do 16, make sure it's 8. And once again, we're going to type into the calculator a half times 8 squared, and then we just add in the pi after. So the area of the large semicircle is 32 pi. For part C, what is the shaded area correct to 1 decimal place? Well, of course, we've got our total being the large semicircle minus the small semicircle. This is when you can type into our calculator 32 pi minus 8 pi, and this is where we get our decimals. If you were approximating earlier, your answer will be less correct than if you waited until now. So the area is 75.398 blah, 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 blah. The reason why I say blah, blah, blah is because we only care about the first decimal place. But why would I include all this? It's because the markers like to know that you typed it into the calculator properly. Then we get our area is approximately 75.4 centimeters squared, and that's correct to one decimal place. So the shaded area is about 75.4 centimeters squared. So that's the end of finding the area of composite shapes. And next lesson, we're going to move on to the trapezoidal rule.